So we had seen one question here. We had done the formula of time period. I will be giving you two or more questions for today as a part of homework to obtain the dimensional formula. You need to obtain the dimensional formula for that. Okay, so yesterday we had obtained this formula. Here, okay, you see this question 2.14 and 2.15. See, question 2.14. A book with many printing errors containing 4 different formulas for the displacement y of a particle undergoing a certain periodic motion. So the first one says y is equal to a sine 2 pi t by t. B says y equals this one. So below all these options, you have been given here. A represents maximum displacement of the particle. See. So from this, we have been given here that A is the maximum displacement of the particle. V is the speed of the particle. T is the time period of motion. Okay. So depending on this, we can identify the units on the left hand side and the right hand side. If we identify here, so on the left hand side, we have the unit, we will have the dimensions of length since it is a displacement. Since it is a displacement, so we will be getting on the left hand side, which have the dimensions. Observe the first one, A, y equals a sine 2 pi t over t. So you have to check whether this is dimensionally correct or not. Rule out the wrong formulas on the dimensional grounds. So you have to tell on the dimensional grounds which ones are the wrong formulas. So what are the dimensions on the left hand side? Yes, just one. What are the dimensions on the left hand side?
Sir,
See,
yes, I do
what does y represent? A
the
book with many
displacement.
displacement, right? Y represents the displacement. Since y represents displacement, so the left hand side should have the dimensions m0, l, and t0. This should be the dimensions of the left hand side. Got it? Since it is a displacement, see here, it says for the displacement y of a particle. So that means y is the displacement. So y is the displacement of the particle. Now here, what about A? See, A is the maximum displacement. Since A is the maximum displacement, so what will be the dimensions of A?
Sir, it will be same, right?
Yes. The dimensions of A is also displacement. So the dimensions of A should be length. Okay. Okay. And see, it is sine 2 pi t by t. So what are the dimensions of sine theta? Have you ever thought what are the dimensions of sine theta?
No, sir.
No. See, sine theta is taken as a ratio of two sides, that is perpendicular by hypotenuse. Perpendicular is a type of length. Hypotenuse is also a type of length. So length by length cancels, and hence sine theta should be dimensionless. Okay. So that means this complete is a dimensionless quantity. And out of this, the value of theta, we had seen that theta is represented as L by R, length of arc by radius. So the dimensions of theta, they should also be dimensionless. We know that theta is also a dimensionless quantity, right? Since theta should be dimensionless, so whatever is written after this sign, that should also be dimensionless. So here it's written 2 pi t over t. So this should be a dimensionless quantity. Okay. Now we have to check whether this is dimensionless or not. So on the right hand side, up to now on the right hand side, we have the dimensions. Dimensions of A. On the right hand side, you have the dimensions of A. So the dimensions of A are M0, L and T0 in the first one. The dimensions of theta, sine theta, it is also dimensionless. And if you observe the dimensions of this 2 pi t by t, so it is 2 pi is a constant number multiplied by t and divided by t. So this is also a dimensionless quantity. Now we can observe that this is a dimensionless quantity which adheres to our assumptions, which adheres to our things, that we can observe the angle or theta to be dimensionless. So this proves here, it shows that theta is dimensionless. So this formula seems to be dimensionally correct, right? On the left hand side, A and Y, they have the same dimensions. So we are getting here sine theta should not have any dimensions. So there is no dimension, and hence the dimensions of left hand side should be equal to A. And see, LHS and RHS, they are equal. So the first formula, it seems to be dimensionally correct. If you observe the second formula, see, the second formula, according to the second formula, we get here y equals, we get here y equals A sine Vt, where V represents the velocity and T represents the time. So now you can see our first condition, we can observe that the dimensions of LHS and RHS, they are same. This is also displacement L, this A is also displacement L. So both the dimensions are same. Let us check about the dimensions of theta. Since theta should be dimensionless, so do you think that V multiply T, what is the dimension of V multiply T? Yes, just one. What should be the dimension of V multiply T? V is velocity or speed.
Sir, I
Yes.
didn't hear. So could you repeat?
What should be the dimensions of V multiply T? Dhananjay?
Yes, sir.
What should be the dimensions of V multiply T? Yes. What should be the dimensions of V multiply T? Dhananjay, can you obtain the dimensions of V multiply T?
Sir, will it be
Hmm?
1 minute, sir? Sir,
Yes.
M0, L1, T
Hmm.
minus 1, maybe.
T minus 1 or T0? See, you are almost correct. See, you have to use the dimensions of velocity, which is L T minus 1, and you have to multiply it with T. So T means T to the power plus 1. So what should be the final dimensions then? Shouldn't it be LT0? Okay.
Okay, sir.
So we get the dimension here M0, L, T0. So these are the dimensions of theta. in the second formula, we observe that theta has a dimension. Here it should be a sine theta, and theta should have a dimension. Theta is having a dimension. But as per our knowledge, we know that theta is a dimensionless quantity. Theta does not have any dimension. It is a dimensionless quantity. So this formula is incorrect. The formula B is incorrect. It is false. What about the formula C? See, check if you check out the dimensional formula of C, if you check out the dimensional formula of C, so again, if you check left hand side has the dimensions y, which is just L. On the right hand side, you get A by T. A is L and A by T is LT minus 1. So clearly the dimensions of LHS are not equal to the RHS, and hence this is also a wrong formula. This is also a wrong formula. Okay. What about this last one? Let's check if the last formula is correct or not. So dimensionally, we can observe that the last formula is dimensionally correct. See, the dimensions of y and the dimensions of a, they are the same, and a is multiplied with the constant. So this is a dimension, both of them, they have the same dimension. Now we check for the theta. The value or dimensions of theta, they are again dimensionless here for both of them. So they are dimensionless for 2 pi t by t and 2 pi t by t.
Yes, sir.
Okay. Okay. So since this formula D, it also seems to be dimensionally correct. So the questions, I know that they were a little bit tougher one for your level, but still I hope you would have understood what all we are talking of here.
Yes,
Yes?
sir.
Okay. So let's say some questions which you might be able, which you should be able to do. Let me give you some of the questions. Hmm. I see some other question. Let's see. 1 minute. Just what I don't think. Hold on for 1 minute. I'm taking out one of the assignments.
Okay.
Okay, I got some of the questions. Just let me share them with this team. Okay, so here, one of the questions we did yesterday, we have a similar type of question. I think you require a practice of such a question only. Let's see. See the question. The frequency n of a stretched string depends upon the tension force F applied, length L of the string, and mass per unit length m of the string. To establish a relationship among them, suppose that the frequency n depends on the tension raised to the power A, length raised to the power B, and mass per unit length raised to power C. Then you have to obtain the formula for frequency. Yesterday we did one of the formula for the time period. We- Can you start with? कहाँ तक पहुँच गए? कहाँ तक पहुँच रहे हो? चल चल रहा है. Okay. Yes, can you try doing this out? Jaswant and Dhanunjay,
Yes, sir.
try doing this. How we will start? Yesterday we did one of the question on the time period. Okay. See, you will write here. It's given that the frequency n, it is proportional to whatever is proportional to the tension. So tension raised to the power A, length raised to the power B, and mass per unit length, which is m raised to power C. Remember here, m is mass per unit length. Okay. So m will have the dimensions. What will be the dimensions of m? This is mass per unit length. So m will have the dimensions m, L minus 1, T0. So these are the dimensions of m. T is not the time, T is tension, which is a type of force. See, tension is a force. So the dimensions of T would be the dimensions of force, which is MLT minus 2. Got it? And L is the length of the spring. So L will have the dimensions. N is the frequency, and frequency has the dimension T minus 1. That is Hertz. So N will have the dimensions M0, L0, T minus 1. On the left hand side, we have. On the right hand side, we should have the dimensions. T is 4, so which is MLT minus 2 to the power A multiplied with L to the power B, and this multiplied with mass per unit length, which is ML minus 1 to the power C. Now, can you try to do this? Just you need to find out the values of A, B, and C. The way we had done yesterday, in the same way, you have to find the values of A, B, and C. Okay. So see, you will be putting these dimensions as M0, L0, T minus 1 equals here dimensions of M to the power A, L to the power A, T to the power minus 2A. Then here you have L to the power B, M to the power C, and L to the power minus C. Now collect the dimensions, collect the variables here. We have M to the power A plus C, L to the power we have A plus B minus C, A plus B minus C, and we have T to the power of minus 2A minus C. Now just compare. So you have A plus C equals 0. From the first comparison, we get here A plus C equals 0. Then we have from here we get A equals minus C. The other one we have here minus 1 equals minus 2A minus C. That is the powers of T we are comparing. Now put the value of minus C as A. So we get minus 1 equal to minus 2A and plus A. So you get here minus 1 equal to minus A. So A is equal to 1. One of the values we got A equals to 1, and hence C should be equal to minus 1. And now we need to find out the dimensions of B. What are the values of B? So we take here A as 1, C as minus 1. So and compare. So what we get here, we should be getting A plus B minus C should be equal to 0. See the dimensions of L here and the dimensions of L here, they should be the same. So A plus B minus C, we already know the value of A and C. If you put the value of A and C, you get here 2 plus B equals 0, and hence B equals to minus 2. Now we can put all these values and obtain the value of frequency. We can get here now, we'll get here the N is equal to, we'll get N proportional to T to the power A. So we'll add T to the power A is 1. So that's the same thing. A we have got 1. Then L we have got minus 2. So L to the power minus 2 and M to the power minus 1. So it will be N proportional to T over ML squared. This is the frequency of vibration. Got it? Got it?
Yes, sir.
Yes. Okay. So I'll be posting you a few more questions similar to this. We'll see some more questions here. Limitations, no. Uh, okay, see this one. Question number 10. Find the dimensional formula for bulk modulus B using expression. This one you have to find out. Find the dimensional formula for bulk modulus B using the expression V equals to under root B by rho, where V is the velocity and rho is the density. You have to find the dimensional formula of B. So for that, we just need to rearrange the terms. We get here V squared equals B by rho, and hence V square multiply rho will be equal to B. So can you tell me the dimensions of B? V is LT minus, this is LT minus 1 whole to the power 2 multiply rho. Rho is ml minus 3. So you get the dimensions of B as L squared T minus 2 ml minus 3 equal to B. So the now dimension m L minus 1 T minus 2. These are the dimensions of bulk modulus B. ml minus 1 T minus 2. In the similar way, you can try some more questions. So bye both of you. I hope you have you can take a screenshot of this
Yes,
and
sir.
you can
Yes,
take
sir.
a screenshot of this
Yes,
and
sir. We'll take it.
okay, take this question 11. Try to do question number 11.
Okay, sir.
Okay, bye.
Thank you, sir. Have a nice day.
Okay, you